Welcome to this video on the introduction to vectors and vector operations. We will explore the fundamental concepts of scalars and vectors and how to perform basic vector operations. Scalars are quantities with only magnitude or size, like temperature, mass, and time. Vectors, on the other hand, have both magnitude and direction. Examples of vectors include velocity, displacement, and force. The key difference between scalars and vectors is that direction matters for vectors. A scalar is just a number, while a vector is a number accompanied by an arrow showing its direction. A resultant is the single vector that represents the combined effect of two or more vectors. You can find resultants using scale diagrams by drawing vectors to scale, using the parallelogram method, and measuring the final resultant vector. For parallel vectors which are in the same or opposite direction, you add magnitudes if they are in the same direction. You subtract magnitudes if they are in opposite directions. For example, 5n north plus 3n north equals 8n north. Antiparallel vectors are in exactly opposite directions. To calculate their resultant, subtract the vector magnitudes, and the direction of the resultant is the direction of the larger magnitude. For instance, 7n north minus 5n south results in 2n north. When adding perpendicular vectors, which are at right angles, use the Pythagorean theorem to calculate the resultant. The resultant equals the square root of a squared plus b squared. Trigonometry is used to calculate the angle. Vector decomposition involves splitting one vector into two perpendicular components. This is useful for analyzing complex motion, as the total vector remains unchanged and aids in various physics and engineering calculations. Practical vector decomposition is used in many fields, including physics problems, engineering design, navigation, and analyzing projectile motion. To calculate vector magnitude, measure the vector length, use the scale accurately, and apply the Pythagorean theorem if necessary. Tools needed are a ruler, protractor, and calculator. Vector direction can be represented using arrows, the angle from a reference line, or a coordinate system. Always include the length, angle, and reference direction when representing a vector. There are several methods for vector addition: the graphical method, the algebraic method, and the trigonometric method. The choice depends on the problem complexity, available information, and required precision. Common vector mistakes include forgetting direction, using an incorrect scale, mixing scalar and vector operations, and not checking units. A good tip is to always draw and verify your work. For vector practice strategies, draw vectors carefully, use a consistent scale, check your calculations, verify both magnitude and direction, and practice regularly. Vectors have many real-world applications across various fields, such as physics, engineering, navigation, sports science, robotics, and aerospace design. To reflect on this video, consider explaining the difference between a scalar and a vector, describing one vector addition method, and sharing a real-world example of a vector application.